In the last segment, we showed how to assign oxidation numbers and then look at how they change to determine whether oxidation or reduction has occurred. There are rules, and the rules are basically uncombined elements have an oxidation number of 0. Oxygen is almost always -2, hydrogen is almost always +1, and then all the oxidation numbers have to equal to the charge and magnitude on whatever it is that you're looking at, which I call the species. So we looked at a couple of these on the top of page 4 in your lecture notes, and we saw that this combination reaction is also redox. We saw that this half reaction is only oxidation, which means we have to find something else that's being reduced to pair them to. So let's try the examples on this page and let's see if we can determine whether oxidation or reduction is occurring. Okay, so we're going to go from SO2 to sulfate. -2, because of our rule for oxygen, that means 4 minuses come to the party. Everything has to add up to 0 because there's no charge on it, which means the sulfur here has to be a +4. On the sulfate, -2, and there are 4 of them, which means that there are 8 minuses coming to the party, so to speak, and everything has to add up to -2. So whatever the number on sulfur is, -8 has to equal -2, which means that the number on sulfur is +6. So therefore, this is showing that SO2 going to SO4 2 minus, our oxidation number goes up. So this shows oxidation. Or stated differently, the SO2 is being oxidized. Permanganate, I'm going to make the negative there more obvious. All the numbers in permanganate have to add up to -1 because there's a -1 on the ion. -2 for the oxygen. -2 times 4 is -8. So there are 8 negatives coming to the party, so to speak. So the number on manganese, -8, has to equal -1. So the number on manganese is +7. When I go to MnO2, this is neutral. So now all these have to add up to 0. -2 means that there are 4 negatives coming to the party, so to speak. So the number on manganese, -4, has to equal 0. So our number here is +4. Therefore, MnO4 minus to MnO2 shows reduction, or I could say permanganate is reduced, which means that I could pair the two of these together in theory, because if I have oxidation, I have to have something else that's being reduced. Bromine, 0, it's uncombined, to 2 bromides. I'll make that negative more obvious. -1. Doesn't matter that there's 2 of them. I just put the 2 there to balance it. By the way, you notice that this half reaction isn't balanced. Okay, neither is that one. We don't care. If you take another chemistry class at the majors level, you would figure out how to balance half reactions. But for our purposes, we're just recognizing whether redox has occurred, or whether it's oxidation, or whether it's reduction. The number goes down. Therefore, Br2 is reduced, 0 to -1. So I could not pair this half reaction with that half reaction because both of them are being reduced. I could, however, pair this one with this one. Okay, and then last but not least, CH4 +1 for the CH4. It's neutral. You have 4 pluses coming to the party, so our number on carbon has to be a -4. Notice that this is not ionic, so we're not splitting it into ions. We're putting on what we call oxidation numbers. The carbon dioxide is also neutral. The oxygen gets a -2, So we have 4 negatives coming to the party. The number on carbon, minus 4, has to equal 0, so our number is plus 4. Therefore, CH4 to CO2 is showing oxidation, or I could say this is oxidized, okay? Or I could say CH4 is oxidized, okay? Either way, what you have to do to be successful at this is to assign oxidation numbers and then see how they've changed. All right, so let's put these into entire reactions and see if we can figure out what's happening overall. Now, CH4 to CO2 is part of a larger combustion reaction, which we've seen before down here. Now, balancing aside, we can easily balance this, right? But not all redox reactions balance quite as easily. Now, we've recognized this as combustion, but let's also assign oxidation numbers and show that this is redox. This is uncombined, so it gets a 0. Hydrogens are going to get a plus 1. Oxygens are going to be given a minus 2 when they are part of something else. Okay? So that leaves us with carbon. 4 hydrogens means there's 4 pluses, and everything adds up to 0, which means the number on carbon has to be minus 4, which is just what we showed up here. This one's complete, which leaves us with the carbon over here. 4 minuses come to the party. There's no charge on the carbon dioxide, so the number on carbon minus 4 has to equal 0. So that gives us a plus 4. What has been oxidized? CH4, which is exactly what we have over here, because the number goes up by a lot. What has been reduced? Our oxygen starts out as 0, and it ends up as a minus 2, and it ends up in a minus 2 in 2 places, which is fine. It's kind of like having sugar. Sugar can go into cake, and it can go into frosting. It can go in more than one place. So this is showing that our O2 is being reduced. So this shows us that combustion is also redox. So we've seen that single replacement is also redox. We've seen that combination is also redox. And now we're seeing that combustion is also redox. And we can prove that by either writing a net ionic equation, if it's possible, or we assign oxidation numbers and look for changes. Okay, so this is our familiar single replacement. 0, 0, uncombined. These are ionic. And notice, by the way, that the equation isn't balanced, but it doesn't matter because all we're trying to do is recognize redox. Chlorine is a minus 1, and there are 3 of them, which means the charge on this gold has to be a plus 3. So since it was gold 3 that went into making it, gold is a plus 3, chlorine is a minus 1. The tin compound is the same way. This is ionic. Chlorine, 2, with a minus charge, that's a chloride, which means the charge on tin has to be a plus 2. What that means then is since tin 2 went into making it, that the oxidation number on tin is plus 2 and the chlorine is minus 1. So this is showing that nothing is happening to the chlorine, and indeed if we wrote a net ionic equation, we would see that that chlorine is a spectator. Nonetheless, our goal here is to say, well, what's been oxidized? Well, tin goes from 0 to plus 2. So the tin, by the way, which is a metal, right? Just like the gold is a metal. The tin has been oxidized. What has been reduced? The gold plus 3, or we could say gold 3 chloride. If we write a net ionic equation and we are assuming that these are both aqueous, then our net ionic equation says that tin plus gold 3 yields tin 2 plus gold. The chloride is a spectator. So let's try to pull out the half reactions and balance the equation by balancing electrons. So tin plus 2, 2 electrons lost. Gold 3 to gold, we have to gain 3, which means that in order for our electrons to cancel, we have to make 6. So we're going to multiply this one by 3, 3, 3, 6, and we're going to multiply this one by 2, 6, 2, and 2. The 6 electrons will cancel. We will add these together, and I'm going to write it over here. I'm going to get 3 tin plus 2 gold 3 yields 3 tin 2 plus 2 gold metal. And this is our balanced skeletal equation, which we could have just done up here. 2, 3, 3, and 2, which is exactly what we have down here.